Okay. All right, here we go. This is going to take us close to the entire period. I want to get most of this 1-9 in today. So then tomorrow when you come to class, there's not a lot to talk about. Just wrap up some things and then turn you loose and get you working, okay? So you won't get much work time today, I'm sorry. Okay. All right. But this assignment is not due until when? Monday, okay? All right. So we're talking about what? Inverse functions. So here's a quick example of inverse function. Let's go like this. If I give you x plus 3 and I say equals 10, an inverse function is right here. It says informally this is what it is. Inverse functions are those that what? Undo each other. So if I start with this number x, and then I get 3 bigger, how do I get back to x? Yeah, don't I just go minus 3? So doesn't subtraction and addition undo each other? And you end up with the answer, of course, 7 equals x. But this is undoing this, right? So inverse functions undo each other. So look at this function right here. What function would serve to undo f of x equals 3x? Okay, so watch this. This is your function, 3x. So what you're doing is you're putting in 1. And when you put 1 into your function, what do you get? 3. When you put 2 in, you get? Okay, 3 gets 9, 4 gets 12. You put it in, right? Undo it. Undo it means this. I want 3 to go back to 1. I want 6 to go back to 2. I want 9 to go back to 3. What function would undo that? I'm going to just call it g of x. This is the inverse function. So I want 3 to go back to 1, and 6 to go back to 2, and 9 to go back to 3. Gotta use the variable x.
X over 3.
3 times x. What undoes addition? Subtraction. What undoes? Yeah. What undoes multiplication? Division. Wouldn't I have to do this? Wouldn't I have to do that? Check it out. If you put 3 in, 3 right here, are you going to get it back to 1? Yeah. If you put 6 in, are you going to go back to 2? Yeah, 9 would go back to 3, 12 would go back to 4. This division undoes multiplication, right? So really what an inverse function does is, the function moves you this way, but the inverse moves you right back to where you started. So I started at 1, I put it into the function, got what? 3. Then I put 3 into the inverse function and went right back to what? 1. It's a what? It's a circle. Pick any point and it works. Any point. Good? Put 4 in, ready? 3 times 4 is 12. Now put 12 into the inverse function. And you get right back to what? 4. Okay? So, can I ask you this? If these are the points that go with the function 3x, what are the points that go with the inverse? Yeah, but it's kind of the same ones. So what?
It'd be 3 and 1.
Yeah, I put 3 into my inverse, got 1. I put 6 into my inverse, got what?
2.
And then I put 9 in and got 3. So what do you notice about functions and inverse functions? The x and y get switched. Does this ring a bell? Do you remember last year in Algebra 2 we're looking for inverse functions? Don't you remember switching the x's and the y's? Your faces aren't saying yes to me. Some of you are trying to, I don't know, if you're faking it or what. I hope you do remember, because really that's all you did. You switched x's and y's. Okay, so, hang on now. It says this. The next slide says, if your function f of x and g of x are truly what? If they are inverses, then you know what? this composite should always give us what? X. This composite should always give us X again. What you start with. You might not remember what I'm saying. Let me try this. F of G of X. Okay? Would you please look at those ordered pairs that I just gave you? When I started, let's say I put this one in. G of, I can't remember. Wasn't it 6? Let's try 6. Put 6 into the inverse. What did you get? You got 2, didn't you? Okay. Are you looking at the previous slide? Okay, now put 2 into your function. What did you get? 6. Are you seeing what I'm seeing? You started with 6. You ended with what? You start with X. What should you get? X. You start with X. You should get X. And that's what they're saying. If you are truly looking at 2 inverses, they basically get you right back to where you started. I put in 6. I end up with 6. Okay? How do we prove that this and this are inverse? How do we prove it? It's right here. You have to do 2 composite functions. F of G of X better be X. G of F of X better be X. If they're not X, they're not inverses. Believe me, when I do this to you, they're inverses. You better get X. All right, you ready? Let's do the work. This is proving. Show means to prove that they are inverses. The only way to prove it is to do this. And you should know you're going to get what? You're going to get X. Here we go. This is yesterday's lesson. F of G of X is the same as F of, what is G of X? Yeah, it's right there. X minus 2 over what? 3. Okay. Yeah, so this is what we did yesterday. Now we took the inside function and stuck it where? Into the outside function. Well, the outside function is F. There's F right there. So now you need to do what? I can't see it anymore, but I think it was 3 times X, then what? Plus 2. So what are you putting into the X value? G of X. Okay, so that goes here. Right? Okay, now you just perform the algebra part. This is 3 over 1 times X minus 2 over 3 plus 2. What would you do? Cancel the 3's, and you get what? Now what? And the answer is what? Didn't we already know the answer was supposed to be X? Yeah, you will get X. But the thing is, you have to show your what? You got to show the work, because the work is what gets you the points on the test. Because I know the answer is X, and so do you. Because they said, prove it. Prove that they're inverses. Well, they're inverses. Prove it now. Okay, let's go do the other one. And the other one would be not F of G of X, but what?
G of F.
G of F of X, right? Okay, and that would be G of, what's F of X? 3x plus 2 needs to get plugged into what? Function G. Well, function G is right there, so we're going to plug, here we go. Okay, that's X, so I'm going to leave that blank, minus 2 over 3. So in for that X, right there, I'll stick this number. That's a number, it's not, I know it doesn't look like a number, but it is. Right? Okay, if I'm looking at that fraction, I'm looking at the numerator and I see 3x plus 2. There's no multiplier, so really do I need the parentheses? No. Didn't really need them. Okay, so now what would you cross out? Hopefully the 2's, and your answer now is 3 times x over what? 3. Yeah, this is really 3 times 1. So as long as you have multiply over multiply, go ahead and cancel. And the answer is what? X. X. Are they inverses?
Yes.
The answer is yes. They are inverses. Why? Because when I did the composites, I got x and x. So now, today's lesson has yesterday's lesson in it. Now you're doing composites. And you have to do it. You have to know how to do it. Okay? All right. This is a quick shot at how do we show inverse on our paper. It says here, if the inverse of f of x is going to be written like this. So when you take f of x and call it your function, this with the negative 1 up above it is now considered what? The inverse, right? So do you remember the first slide? The first slide I gave you, no I didn't. I gave you this, didn't I? I said f of x is 3x, right? And then I said, oh, what would be the inverse to this? And I said g of x, right? And I said this would be the inverse, right? Well, that's me just saying f is the function, g is the inverse. Now, using the notation, you would write what? Not this, you'd write f inverse of x equals this. Okay? So I want you to know in the back of the book, when you see that, this function is the inverse to this function. Okay? Just a quick statement on that look. Okay? Keep going, keep going. All right, all right. I had all this typed in this morning, and I must not have hit the button save. So, I'm just going to tell you what the horizontal line test is, and then I'll read you what the definition says, okay? Okay, let me do this. Let me show you a parabola, okay, a quadratic function. Now, the horizontal line test is simply this. If you draw horizontal lines through your function f of x, okay, if you hit the function 2 or more, then what? No, now this is the function. No, what do you think we're looking for today? We're looking for inverses. There's no what? There's no inverse. Okay, there's no inverse. And that is a quadratic function. So what do you think about all parabolas? Do they have inverses? No, they don't. Okay. Okay, can I just read it to you now? And then if you want me to, I will write this out for you, and then you have to write it up. Okay? Here's what the horizontal line test says. A function f, look, right here. A function f has an inverse if and only if no horizontal line intersects the graph of f at more than one point. Okay? I don't know if they say that the best way, but really all it is, if you hit the graph, how many times? Twice or more than what? No inverse. Now, what would have an inverse? I want to know. Not quadratic. I know that. What? Cubic? Okay, so a cubic function would look like what? Draw it with your hand. Just draw it with your hand. Okay, now I saw it. Something went in that way. Okay. Right? So that's a cubic function. Does a cubic function have an inverse? How do you know? The horizontal line test. What about it? Horizontal line. How many times you hit it?
Once.
Just once. If you hit it just once, then what? Has an inverse. And guess what your job today is? Go find it. Has an inverse, okay? Because you hit it once. So cubic will have one. Quadratic won't. What about linear? Except one. Except one. What's the only linear function that doesn't have an inverse? A horizontal line. A horizontal line. Draw a horizontal line through it. How many times you hit it?
Many.
Millions. Billions. Okay, so no inverse to that one. Okay?
All the
All
time.
right. Now, go to 1 to 1. Again, definition's not there. Here, I'm going to tell you this. When looking at a graph, okay, this is what it says. When looking at a graph, one-to-one functions are functions that must pass both the vertical line test and the horizontal line test. They pass both tests. Okay, so for example, if I look at your cubic function, okay, there's your cubic function, correct? Okay, does your cubic function pass the vertical line test? Okay, so because it passed the vertical line test, is this a function?
Yes.
So is it a function? The answer is yes. Okay. But it's a one-to-one function. One-to-one means it passes what?
Both.
Both. So here's the other test. The other test is, does the cubic function pass the horizontal line? Did you hit it once? Yep. So what does that mean to you? That means, does it have an inverse?
Oh, yeah.
Yes. Yes, it does. So if it's one-to-one, it passes both tests, which means it is a function, thumbs up, and it has an inverse, thumbs up. You get a double thumbs up. This is when everything is good. Okay. So one-to-one just basically means that. Do you want me to write this all out for you? It also says this, each y value corresponds to exactly one x value. That's kind of the reverse of what a function is. To have an inverse, each y value gets exactly one x value. But that horizontal line test is telling you that. Here, another thing it says is a function f has an inverse function. If and only if it is one-to-one. Well, that means you got to pass both tests. Okay? To have an inverse and to have a function and an inverse. I'm not going to get too carried away with this. Basically, it means what? Must pass what?
Both tests.
Both tests. You want me to write that? No? Don't want me to write it? Must pass what? Both
Line test.
VLT and what else? HLT. Vertical line test, horizontal line test. Okay. Keep going. Okay. This one you can do a little bit more work on your own. Let's just try this. Would you please graph that function f of x and identify 3 points on your graph paper? Okay. Make a nice looking piece of graph on your slide somewhere, and try to get yourself 3 points on your function right here. Here's your function. I'm just doing this one right here. Call this 1. Then we'll do 2. Then we'll do 3. Please go back to 1-7, transformations. It's not hard to graph that. It is which parent? Square root function. The square root parent, okay? And it's your square root parent. Move where? To the right. How far? To right. Okay. So I go from 0, 0 to what? 2, 0. Start there. And if you know what your parent looks like, there's hardly any thinking. My parent starts here but goes where to the next point? Over 1, up 1. Then from there it goes over what?
So 4.
4, up what?
2.
2. And that's pretty much my square root function, right? And then it says to label 3 points. 2, 0, what's this one? 3, 1. What's this one? Should be, 6, 2. All right, did it. Step 1 is done. All right, step 2. Using those 3 points, would you please graph your inverse function? This might have been really hard for you because you don't know what to do, or this could have been really easy. What do you know about functions and their inverse? Switch x and y, yeah. So all you have to do is take your function, take all your points on your function, and do what?
Switch them.
So 2, 0, 1, 3, 2, 6. Just plot them and connect them and see what happens. There's 0, 2. There's let's see what's next. 1, 3. 1, 3, and then there's 2, 6. Somewhere up here. See it? There it goes. So which one's the function? This one. Which one's the inverse? The green one. Okay, done. That's how you do that today. Whenever they tell you to graph your, go graph your inverse. Don't graph your inverse. First graph your function, switch the x's and y's, and then graph the inverse. Okay? Last but not least, number 3. Graph the function y equals x. On the same set of axes, so just right there. Put it on that picture. Graph y equals x. Hopefully you notice y equals x is really in slope-intercept form. It's y equals 1x plus 0. Where's the y-intercept? 0. Slope? 1 over 1, which means what? Up 1, over 1, up 1. I wish I had graph paper, but I don't. 1, 1, 1. Okay, so basically it looks like this. There it goes. There it goes. Okay. So now the next thing I'm going to ask you, and I should have put this down. Question. What did you notice when you did this? There's symmetry and there's reflection going on here, right? Isn't the function f of x and the inverse function f negative 1 of x, aren't they just reflections over this line? Yeah. So guys, 2, 0 is reflected straight across to 0, 2. 3, 1 is reflected where? 1, 3. 6, 2? 2, 6. They're equal distances away. I know it doesn't look like that, but that distance and that distance are supposed to be what? The same. But I don't have graph paper, so it doesn't look that good. But do you get it?
Yes.
So what should you write here? What did I notice? I noticed that f of x and what? The inverse of x, f of x, are what? Reflected over what? Y equals x. Not the x-axis, not the y-axis. It's reflected over y equals x. Every single time. Every single time. So when you draw these, shouldn't you just kind of be able to look at it and go, oh, look, it's reflected over y equals x. Which basically means if 2 comma 10 is on your function, what's on your inverse? 10 comma 2. Okay. All right, next. This is just a quick statement. Sometimes your domain is restricted. The question is, why? How come? Why must we restrict the domain when finding the inverse of this? And by the way, on yours, can you see the equal sign? I feel like your equal sign looks like a negative x squared. It's just f of x equals what? X squared minus 3. Anyways, the question is why do I have to restrict my domain? Because why? Quadratic? What do you mean by that? Now, x squared can be positive, x squared can be negative. That one's positive. Why do I have to restrict my domain? Yeah, because it's a square root function. It's actually that function is really a quadratic function. Okay, can I draw you the picture?
Aren't quadratics like this one?
Yep, yep.
And it
It would fail what?
would fail
Horizontal.
Okay, so here's the deal. Look, she's got it. She's getting there. This is x squared minus 3. That'd be down 1, 2, 3. Wouldn't it just be this? Right? Okay, so why must we restrict the domain in order to find the inverse? Because this function has no inverse, right? Look, horizontal line. How many times did I hit it? Twice. Why must we restrict it? Because f of x doesn't what?
Have an inverse.
Doesn't have an inverse. That's why. So to make it have an inverse, you know what I have to do? I have to restrict your domain. What am I going to tell you? Your domain in this problem is, I might tell you this. So now what am I telling you to only look at? 0 to positive infinity. So if you look at only 0, that would get you what point? That
Three.
point. 1 would get you that point. So really I'm telling you to only look here, right? I'm telling you to what? Yeah, ignore the other half of the parabola. Just ignore it. And now look at this half of the parabola. Does it have an inverse? Now it does. So when you get to the book, guys, when you get to the book, they're going to restrict you. They're going to say, there. Now, can you do this problem? Yes, because it has an inverse. So if they ask you questions about the inverse, now it has an inverse because I told you don't look at the other half. Just look at the right side or just look at the left side. Yeah? Now do you remember what I said in the very beginning? What's the objective here? When we walk out that door in 10 minutes, you gotta know how to find an inverse. And you don't even know how to find it yet, and that's the next slide. So let's go find the inverse. Ready? I would like you to do what? Find the inverse of what? That. And then when you're all done, verify, which means prove it. I did that on the second slide. Okay. There are actually 4 quick, easy steps, okay? First step. Let's do this. It's really quick and easy. Just replace f of x with, with y. Because f of x is y, correct?
Yeah.
Yeah, so just go like this. Cross that out and just put y equals x. There, that was easy. Good? All right. Whoa, whoops. I forgot to, shoot. This is actually 2, then 3, then 4. No, okay, step 1. Forgot to say this to you. If I say find the inverse, check to see if the inverse exists. You know if it exists or not? It's a what function? You know it's a cubic function, guys. A cubic function goes like this. Yes, there is an inverse, right? So I could say right away, yes, there is an inverse. Let's go find it. Now replace f of x with y. Did that. Third step would be this. Really simple. This is when you switch what? X and y. Because the inverse, the function and the inverse, the x's are switched. So we just have to take this y, this x, and switch it. That's it. Write this right behind it. Go like this. Parentheses. Now solve it for what? Solve for y. So go ahead and solve that for y. Right? Add 3 to both sides. Now what? Cube root. Right there. Right there. And y equals what? Yeah, cube root of x plus 3, right? Good. The last thing you have to do is this. Let's say replace the letter y with what? Inverse notation. Don't say y equals, say the inverse equals, right? And that's pretty much it. So guys, you could probably just do what? Cross that out and put what? This is the inverse, right? Inverse. The inverse of f is right there. Good?
Yeah.
There is one more thing they asked you to do, which is what?
Verify.
Verify. It's right here. Verify. And then to verify, I don't know if we have enough time to do this, but look at this. This was slide 2. Verify that, oh, I didn't mean to do that. I'm sorry. I meant to say what?
The inverse of that.
Yeah, f of the inverse of f should get you x. And then do the inverse of f of x. Should get you x, correct? That's your job, to actually do all that. Looking at the time, there's still 5 minutes. I think we can hammer this out. Who can tell me the inverse function? Well, it's right there, right? The inverse function is right there, the cube root of x plus 3. Where does that go? In for f. But I can't see f. What's f?
X cubed plus 3.
X what?
Cubed.
Plus,
Minus 3.
oh, minus 3. Okay, minus 3. And what goes in there?
Cubed plus x.
Yeah, the cube root of x plus 3. Guys, these work out really nice, don't they? The cube root of x plus 3, cube it.
So x plus 3.
Yeah, x plus 3. Minus 3. Did it work?
Yeah.
Yeah, it worked. It better work. Or else we did it wrong. I mean, but I think we did it right. Okay. What's the other one? F inverse of f of x. Well, hang on. What's f of x?
X cubed.
X what?
X cubed minus 3.
X cubed minus 3. Okay, that goes into the inverse. Well, the inverse is just a little higher up. Let me go here. There's the inverse, right? So this number has to go where? Right there. So you put cube root of, in place of x you put x cubed minus 3, then what? Plus 3. 3's will cancel out, yep. X cube root of, x cubed, that and that are gone. Answer? Good?
Yes.
So I found the inverse, then I proved to you I was correct. Okay? Alright. How much of 190 did I teach you? Not all of it, I'd say 90%. Almost all of it. Which means, well, isn't there another couple slides behind this? Oh, there's a couple of slides that I'm going to give you tomorrow.
There's 110 and 150.
There's a couple more I want to talk about. I'll give you. Okay, this 1-9 trickles into what? Monday. So tomorrow, let's do a little more talking and make sure you're okay about inverses. And then come back Monday next week and we'll kind of wrap up 110-ish. Looks like we're testing when? Thursday? Thursday next week.
No, no, there.
I actually got an extra. And so then I kept the extra.
No.